Well, good morning and welcome to Nani Notes. Today's topic is substitution and, with linear equations, systems of linear equations, that is. If you are following along with the McDougal-Littel textbook up there in that, the upper right corner, Algebra 1, you will find this in Chapter 7, Section 2. Well, I guess in Section 1 you learned a little bit about linear equations, and here we're going to solve systems. Systems means, well, we got two linear equations on the same plane. Perhaps you've already done the graphing, so we're not really going to graph today. You've already done that. We spent a whole lesson on that. We're just going to do the algebra today, and we're going to use the substitution method. Not the only method, but it's the one we're doing today. Are you ready? I think so. Here we go. Okay, I've got two lines here. We'll call it the blue and the purple. And, one's in slope-intercept form and the other's in standard form. Now, I'm looking at this blue equation, slope-intercept, and I'm saying y has this value, 2x minus 1. Well, I'm going to take that value and I'm going to substitute it into the purple equation, which is in standard form. And look at that. We'll use a little color coding to help you see it. So the 2x minus 1 replaces the y. That's substitution. Okay, now it's just algebra. Let's combine those terms. I've got 2x and 2x. That's 4x. And I can solve a two-step equation easy enough. Add 1 to both sides of the equation. Hey, you know where this goes. And then we'll do our division. Divide both sides by 4. How easy is that? Now, that gives us an answer for x. Let's substitute that. Let's pick either equation. I'm going to take the blue one, the first one. I'm going to substitute 1 in for x. And, well, I've got 2 minus 1, that's 1. And that tells me that x is 1, y is 1. How easy is that? And I'm going to do a little bit of a test. I'm going to take the second equation, the purple one, and I'm going to put in 1 for x and 1 for y. And you know what? It works out. 2 plus 1 is 3. So therefore my solution, x is 1, y is 1. And we're going to write it 1 comma 1 since it's an ordered pair. Okay. And again, for those of you following along that have this textbook, that's exercise number 4. So we're going to use, I've added a couple because I thought it was lacking a little bit, missed one point. But I'm going to follow along and select numbers. Here's number 5. Okay, now funny form of an equation, but it's still set up nicely for us. Let's put that blue equation inside the purple. We're going to substitute it there. So now we have to do a little bit more. We're going to have to distribute because I've got 2 x's, so I'm going to have 2 y plus 3's. So I'm going to distribute, and now I've got this expression. I'm going to combine terms, which another way of saying I'm going to simplify, and then I'm going to subtract 6 from both sides. And look at that. Now let me take that negative 1 for the y and substitute back in to the blue equation. That's the top one, my very first equation. Well, if y is negative 1, negative 1 plus 3, well, x must be 2. So I've got a value of 2 for x, negative 1 for y. Take that and so check it in put it inside your purple equation. That's your second equation. So go ahead, replace x with 2. Replace y with negative 1. I've got 4 minus a negative 1 is 5. Yeah, that checks out okay. So it looks to me like my solution is 2, negative 1. Staying with me? I know you are. Okay, how about 6? And again, in the textbook. Another. Now, when should you use the substitution method? Honestly, this is when I like it. when you've got one equation in standard form and you've got one that's in slope-intercept. It just begs to be solved this way. So here we go. We're going to substitute the purple into the blue. What do I do next? You know I've got to distribute. So go ahead and distribute. And since you're getting the hang of it, oh, and do remember when you're distributing here, you're distributing the -7 across this expression. That's -7x, -7, -7, positive 49. Yikes. You can really get in trouble with those signs. That's why you spent so much time in the beginning of the year working on just integer arithmetic. So I'm going to combine the x's, and let's just keep going there. I'm going to subtract the 49 from both sides, and then I'm going to divide both sides by a -3. Beautiful. So there you go. I'm going to substitute into the purple equation because I think that's easier. And I've got y equals 6. X is 13, y is 6. Are we going to test our work? Oh yeah. So I'm going to take that first equation. I've got 4 13s. Hey, that's a deck of cards. That's 52. Minus 7 times 6. 7 times 6 is 42 is equal to 10. That checks out A-OK. So that's my solution, 13, 6. Oh my gosh, is this getting, I hope this isn't boring you guys too. You know, at any point you can pause it, work ahead, and you should, to see that you can, you know, and then just check your work. How about 7? You know, I think in the interest of time, we're going to skip 7, or maybe we'll just go through it quickly. Yeah, we'll go through it quickly. You're going to substitute the blue into the purple. And again, you're going to distribute, combine terms. Feel free to pause this video at any time if you need to digest this. And then, I hate getting interrupted. And then we're going to divide. Remember, you're dividing by a negative coefficient. And I'm going to substitute. Well, I guess I did crank through this one. All right, so we've got a y of 5, an x of -4. Check your work out. Take that purple equation, the second one, and it looks like it works out okay. That's your solution. Remember, the x is, oh, that's not 2, 5. Bad. That looks like -4, 5. Who's that? Who is the editor here? Yikes. Must be looking for a new job. All right. Why was 6 scared of 7? Because 7, 8, 9. Oh, my favorite joke. But honestly, I'm getting tired of doing all these. We need to zip ahead a little bit. 8. Now that's the same as. All right. We'll do the 9 because 9's a little different. This blue equation is in standard form, but what's missing? There's no y. Do you remember how to deal with that? You guys might. Well, this is not a topic of graphing, but I guess remember, no x, it's going to be horizontal. There's no y in that equation. That's a vertical line. All right, I'm going to first take the blue equation and simplify it. And then I'm going to substitute that into the purple equation. And look at this. How easy is this? I'm going to add, I'm going to subtract 6 from both sides. And I divide out that -5, y is 7. But what's x? Well, it's 6. Because x is always 6. This is a vertical line. I'm sure you remember that from the graphing stages. All right, let's see what else we got. Let's zip through these. It's, okay, boring. Yeah. Okay, well, this one's a little bit different. Well, we got the 0. Let's just see if that has any effect on us. You know, actually, I think, yeah, this, all right, now we'll look at this one. We're going to do this one. Then we're first going to notice something. Both these equations are in standard form. So why are we doing this method? Because your teacher asked you to. That's why. honestly, it's probably a bad choice, but let's see if we can do it. I'm going to take this first equation. This is number 11 in your textbook, and I'm going to subtract x from both sides. And now I can substitute. Pretty straightforward. I mean, all I got is, by the way, this is in slope-intercept form. It's got an intercept of 0. You'd call that direct variation. So I can just replace the y with the opposite of x. I'm going to combine the x's. I've got 3 x's is 6, so x is 2. I'm going to substitute, and what am I going to come up with? Y is negative 2. Let me test. 2 plus negative 2 is 0. Now, that's my solution. 2, negative 2. Now, I did give you a hint saying this is really a lousy way to do this problem. Let's look at number 12, see how this varies. Okay. Same thing. I've got two different equations here, but they're both in standard form. Now I'll do it the way your teacher asked you to, or the substitution method, just to show we can. And then maybe there's a better way. So we've got to rearrange one equation. I'm going to take the blue equation. I'm going to subtract 2x from both sides. I subtract 2x from both sides. I've got y equals negative 2x plus 9. I'll tell you, all my students end up doing this. Nobody wants to work in standard form. Everybody wants to just convert it into slope-intercept. So you're used to this. I know you can do this part. So go ahead and just take that value of, take this new blue equation. We're going to stick it into this purple equation, just like this. Ready? And again, a little tricky here because you've got a negative sign out here. You're going to distribute that negative across this blue expression. 4x minus a negative 2x minus a positive 9 equals negative 15. So go ahead and check your integer arithmetic. 4x minus negative 2x, that's going to be 6x minus 9. Okay, well, let's go ahead and add the 9 to both sides, and then we can divide, and we've got x equals negative 1. Now, how about if we did this instead? Instead of doing all that work, I could have just taken these two equations, the ones we were given in the first place, and just add them together. Look at that. 2x and 4x, that's 6x. Y minus y, nothing. The y disappears. That's a method you're going to learn probably in next section. And it comes in really handy right here. And from here you can see that x is negative 6. That would have been the more expeditious way to solve this. And honestly, by the end of the chapter, your job is to decide which method to use. So honestly, you wouldn't have chosen this one. But now that we've got the x, we can proceed. And we can substitute. I'm going to substitute into that purple equation, the negative 1. Now you'd have to do this regardless of which method you used. And we're going to solve for that, and y is 11. I'm going to test. Always check with the other equation. Make sure it works out, because that's how you confirm. And it works out okay. X is negative 1. Y is positive 11. Boy, this is starting to drag on. Hey, sorry about that, but there's just some things you just got to do. All right. That was number 12. This one is not in the textbook. I just made it up because I thought it was missing. And we're going to do this by substitution. We're going to substitute. We'll put the purple into the blue, or as I say in class, the bleh. And I'm going to replace y with 2x plus 7. So again, you've got a standard form and you've got a slope-intercept form. Now, watch what happens here. I'm going to distribute there, the negative sign. And then I've got 2x minus 2x minus 7 equals 3. And as we say, ruh-roh, I take that 2x and I subtract x. I got no more x's. And then I've got negative 7 equals 3. You nuts? That's simply not true. So your job is to interpret that. You get a situation like this. You get a contradiction, we may call it. Negative 7 equals 3. False. Well, you did the math right. Well, hopefully I did it right. And you just got to understand what that means. What that means, these lines do not intersect. And you're saying, huh, is there another way to figure that out? As a politician from Alaska once said, you betcha. I'm just going to take this equation over here and watch this. Let's do a little magic. You know how you like to convert these equations. Go ahead and convert this one. So I'm going to subtract the 2x. I'll line up the equal signs. Subtract the 2x from both sides of the equation. Right? And then multiply both sides of the equation by negative 1. Or take the opposite if you prefer. And check this out. You've got this equation is in slope-intercept form. This equation is in slope-intercept form. They have the same slope, and they have a different y-intercept. They have the same slope, different intercept. They are parallel. And as you know, parallel lines in the same plane, we're talking Cartesian plane here, do not intersect. So we're sticking in the world of Euclidean geometry. Okay. Well, how's that for a neat counterexample? Anybody see that one coming? All right. Let's try another one that's not in the book. I made this one up too. Now again, I've got the purple equation. Looks like I'm going to substitute that into the blue because I've got slope-intercept and I've got standard form. Just made for this. Now, I got the fractions. Can we all multiply fractions? Oh, yeah. You guys got this. I know half. If I take negative 3 halves times 2, well, that's going to be negative 3. So I'm going to just do the arithmetic. 2 times 6 is 12. And I say, ruh-roh again. The x's disappeared. I combine the terms. I combine those two terms. 3x minus 3x is 0. But now I've got a different situation. 12 equals 12 is true. So what does that mean? I think it means they're the same line. Well, let's see if we can demonstrate this algebraically. Let's take a copy of this puppy over here. Okay? And we'll do our algebra thing. I'm going to add y to both sides. All right? So I guess I could slide it like that. See, this time I'm going to convert the slope-intercept into the standard form. And now I'm going to multiply both sides of the equation by what? Yeah, multiplied by 2. Or did I mess that up? Heavens to Murgatroyds, I messed that up. Silly Mr. Banish. When I added, I added 3 halves x to both sides. That should have been positive 3 halves x. Okay, so 3 halves x plus y equals 6. And then when I doubled both sides of the equation, I've got 3x plus 2y equals 12. This equation has turned into this equation. If you can turn one equation into the other, well, they're the same equation. And therefore, um, the number of solutions, infinite. Infinite solutions on this one. Whew. How's that for two special cases? Let's keep this momentum going. You know, three more, I don't know about that. Let me see, 13. Okay, well, we'll do a regular one and 16. No, actually, we're going to do 16 and 17, then we'll call it quits. Now, 16, I like this because you got all these unnecessarily large numbers, and they're both in standard form. So let's do something here. I'm going to rearrange one equation. I'm going to rearrange the purple one. Notice, I don't even have to turn it into slope-intercept. I can just say x equals. That's fine. Now, I'm going to take that first equation, the blue one, and I'm going to divide out a factor of 10 from everything. Just simplify it. Just makes a lot of sense. And now, I'm going to replace the x in the blue equation with negative 2y plus 1. You with me now? I hope you are. I can hear you. All right, so I got negative 4y plus 2 minus 3y equals negative 5. I can combine terms. Now, I have seen my students do this. They'll subtract, they'll make a mistake. They'll add 4y to both sides. Problem is, these are on the same side of the equation. So you're combining terms. So it's negative 7y plus 2 equals negative 5. Then you subtract the 2 from both sides. Then we're going to divide. Oh, and I think this is the one I had to scroll up. Oh, yeah. So we got y equals 1. How's that? So let's take that, and I'm going to substitute that into, I'll just use the purple equation, and I'm going to solve for x. And let me test. Now, I'm going to go back to the original, the blue equation, before I simplified it, just to show that it works. I'm going to put in negative 1, positive 1, and look at that. It works out a-okay. How is that? My solution, negative 1, positive 1. Okay, one more. And you know, this one, I picked this one mostly because this one, the ones I assigned, but I wanted one that does not have an integer solution for x and y. Come on, everybody. You're going to grow up someday and get real jobs, and nothing's going to have an integer solution. So let's go ahead and do this. Let's first rearrange this one equation. And this one was kind of easy, or nice, or jumped out at me. That's the way I would do it, because I got a negative 4y. I'll just add 4y to both sides. So I've turned the purple equation into this. If I wanted to line up the equal signs, that might be more proper. Now, let's take that first equation, the blue one. Replace x with 4y plus 19. Just like we've been doing over and over and over. But this one's got a tiny twist at the end. I've got 24y. 6 19s, 114. Did you know that? I don't know. Well, I guess you could say 6 20s are 120, and then you take away 6. So you see, you're really thinking of this multiplication as like a polynomial. Hey, isn't that cool? Plus y equals 4. Now, I've got a y over there. How many y's? I got 24 there and 1 there. That's 25. Plus 114. And I'm going to combine. And I'm going to subtract the 114. And this is where students will say, whoa, something must be wrong because I didn't get an integer solution. Well, you know, okay, almost, well, real world wouldn't even be that easy. So there you go. You've got finally something that's not an integer. Y equals negative 4.4. Well, all right, so a little bit different. And let's see if we can make that substitution. Let's make that substitution into, we'll put it into the blue equation. And if I take that, and I will add 4.4 to both sides. Now take 4.4 and divide by 6. But it still came out nicely to the tens place. And there you go. Your solution, 1.4, negative 4.4. Now, are we going to test this one? Why not? And that makes it kind of fun, so we can check our integer arithmetic and maybe a little calculator work there. 4 4s are 16, and 4 4s are 16 again. And I'm imagining that 16. I'm sliding that over in my mind. 17.6. That makes sense. 19 equals 19. This tests out A-OK. All right, everybody. I hope you followed along. Pause where necessary. And as Nani always says, pause as necessary. Thank you for watching Nani.